Couple more seats.
You can play the seat by playing some piano.
Yeah, it's been a while since I've played the piano.
It's only a small audience.
I don't know, can anyone here play the piano? Yeah? We would like some music in the intro to this talk. So it's a rare opportunity, you know, to have piano. You get extra points for playing computer game tunes. Does anyone know whose stuff this is? No? Okay.
Do you know what the Wi-Fi is?
Yeah.
I'm quite desperate.
Who has the Wi-Fi? Oops, sorry, my bad. Okay, everyone's gone so quiet that I feel like we should start.
Yeah.
Otherwise, it's just going to get very awkward. It'll be like this embarrassing silence for 5 minutes. So let's start.
Let's do that.
Okay, so the floor is yours.
Okay, so welcome everybody. We are at Fraktio's venue in the classroom, and our office is on the 4th floor. And after the presentations, we are having a sauna. There's like 20 people or something, which gonna pack the whole sauna place. So, but feel free to come if you want. So we can have a queue on there also. So I can pass who's the first speaker, Joonas or? So I don't have anything else to say than welcome warmly everybody.
What about health and safety?
Health and safety.
There's so many of us here that if there's a fire, do we go that way?
Yeah, same way as you went.
Okay.
To get here.
Wi-Fi password.
Wi-Fi passport. Yeah. We can write it down there.
Yeah, I think it's over there.
Do you want to say a few words about Fraktio, how cool you are, that you're looking for artisans?
Yeah. Okay, I can give you some commercial speech.
Limits in the model. Actually, lots on the network, so we.
But Joonas, you can maybe set up in the meantime.
Yes.
We are Fraktio, and we are building web applications and services for our clients. That's basically it, what we are doing for our day job. So we are looking for UX artisan or UX people in general at the moment. And if you are interested, so please contact me or anyone else who has the Fraktio shirt. We can talk about something. But I don't have anything. If you have some questions, Wi-Fi is there. I think there's some maximum amount of clients which can access the Wi-Fi. So please be fast. Yeah.
What is it for?
Sorry.
How do you specialize?
The company. We are building custom applications, like only for the web, and some kind of the service what we are building is always important for our clients. That's basically 2 requirements what we are doing. So basically, web applications and more or less important stuff for the clients. We are not website company or anything like that. But this is not the Fraktio presentation. I can show you something what we have been doing in previously. So.
Yeah. In short, we're not specialized in any framework, not on front side or server side. So we aim to do pretty much everything and learn from them and so on. But if you have nothing more to say, I can start with my presentation. And yeah, it's called The Abundance of JavaScript Libraries. So before I go more deep into it, I'll introduce myself. My name is Joonas Pajunen, and web-based slideshow is very laggy, I see. Okay. I work here at Fraktio. And yeah, today is actually our 1000th day. So we've been around for what? So that makes three
long math.
long math.
But you're not celebrating, you're celebrating 1024th, right?
Yeah, that's true. We have 3 more weeks to actually actually think about what we're gonna do. Today was an ordinary day. All right. I was first tempted to call this that React so last season right now, or something along those lines, and that's based on our joke that we have here at the office that there's a new JavaScript framework every Monday, or if you choose a build tool today, it's gonna be obsolete tomorrow, and you get the idea. So these libraries, they're certainly for various different purposes. There's front-end libraries, back-end libraries, there's visualization, there's UI, there's graphics, there's transpilers, game engines, music stuff, audio stuff, text editors. There's pretty much everything you can do with JavaScript. And I'd like to start with a demo, but well, not really. I have a bunch of screenshots that I did yesterday to search stuff with from the npm. I started with React. There's more than 2,000 results. Angular, similar amounts. There's 12,000 results for Grunt, 4,000, less than 5,000 for jQuery. There's Backbone, underscore, and then I tried to think of something that wouldn't have that many results, like Dojo. It's kind of well, not so hip anymore, I think. Does anyone do Dojo here? Right, cool. I do too, actually, in one project. But anyway, I don't know what these libraries or packages actually are. I didn't go that deep. Then Jasmine, for example, is a testing framework, and over 1,000 different results for a test framework is kind of weird. And has anyone heard of Koa? Yeah, some of you have. There's 800. I think it's a backend library, a framework, kind of like Express. It's from the same guy, TJ Hollowaychuk, and he has 550 packages in npm. This guy, he's like he's either the reincarnation of Fabian Potencier or just does these very small packages. And sorry.
Pseudonym.
Yeah.
Multiple developers with some name.
Yeah, that's a joke. Those of you who do PHP know Fabian. He's the author of every library in Symfony scene and different stuff. But the idea here is that this scene is very saturated with all kinds of stuff, and it's both good and both bad, because this searching for something can become very frustrating when you don't really, you can't browse anything. Let's say you can't browse that something that you needed with React. You pretty much need to know exactly what you're looking for. But these are not really the problems. The problems are actually those libraries that we're not aware of. those that we don't know to search for. But I'll get back to that later, soon. First, I'm gonna rant a little bit about these libraries that keep popping up every few seconds. I don't mean to bash them if you're one of these authors. I think it's a good thing they exist and people make them. But the frustration that we've had and many of us have had, I think they come from the idea that these libraries, they don't really feel a need in many cases. They reinvent the wheel, do something maybe 10% or 20% more effectively and better. And the amount of time you need to invest in these don't really pay off. And also when you get, let's say, 4 different build tools, the community kind of branches out. The let's say the effort doesn't go to one place. It kind of dissipates. All right. Now, yeah, this is the slide I was looking for. So who writes these? Pretty much everyone can write these. JavaScript is very accessible. It's everywhere, and continuing on these rants, I think some of them are written in kind of like marketing purposes. So companies release frameworks and packages in the sense that they're good karma for the company, in a sense that they contribute to open source and help the community. And whereas individual people, they publish stuff on their GitHub pages or profiles, and because your profile is kind of like your CV in a sense. It shows what you can do, what you've done, and how you write code. So I think that's one kind of problem that there exists, where these libraries come from, right? But that's kind of the end of the rant, the negative type of it. And from now on, I want to concentrate on learning. And the problem here with all these options, with this crazy amount of libraries, is choosing what to learn. And when choosing what to learn, you have to think about the return of investment. So learning a library like Angular, for example, is you can get going in a few hours, but really mastering it's gonna take time. And you have this fear in the back of your head that maybe I'm wasting my time. What if I chose the wrong framework, wrong library, and that time I've invested will go to waste? And there's the idea of sunk costs, that if you spend time on something, that amount of time spent is going to affect your judgment. You can't really think objectively after that about that. So, for example, you learn Dojo for, 2 years, then you begin to see it's becoming obsolete, no one uses it anymore. Then you you become like this sworn protector of Dojo, and you use it in every project you start, and you kind of drive yourself into this corner, so to speak. And people sometimes have problems with becoming a beginner again. And following these footsteps can lead you to stagnation. You can also get to stagnation by not learning anything, but I don't think it's a problem with you guys here, since you are here to learn, basically. So how to stay current? There's this thing called neomania. I don't think it's a real word. I mean, it's not in dictionary. I read it in one of Nassim Taleb's book, I think, and the definition is something like that: a neomaniac is obsessed or infatuated with everything that is new. And in this context, I would think it's a person who reads all these different articles and blogs and listens to podcasts, goes to events, tries out tutorials, and really uses their time to keep up. And this can become also very frustrating. It can take up all your time, and well, there's not enough time in the world to learn everything, of course. So I have this another idea that can be an antidote to neomania. So aging in reverse, also known as the Lindy effect. Has anyone heard of it? No. It's the idea that ideas and memes, they're these non-perishable things that, compared to people who when they age, the expected lifetime is getting slower. Generally, that's true. But for technologies and ideas, the older they are, the longer they're expected to survive. So this is something that I try to keep in my mind when I try to look out for new stuff in this JavaScript universe, let's say. And one thing to fit that in is this quote by Isaiah Berlin. I think it's to understand is to perceive patterns. So I try to look for different ideas and patterns, and I don't mean design patterns here per se, but for example, jQuery for me was more about abstracting the DOM and like abstracting away the differences between browsers, and Backbone was about REST API and general structuring. Angular was about two-way data binding. Underscore was about collections, and it doesn't really matter if it's underscore or Lodash or immutable.js. It's the idea behind them. React is about virtual DOM, and I think Flux is a great example on this because it introduces this unidirectional data flow that's the main idea behind it, and Facebook didn't really give us like this very thought out implementation. They just had this one tutorial and one small package, and a few months later we had probably 15 different implementations. So I try to look for these ideas that I can see that will stick around. And I try to look for the tipping point or the critical mass when adoption and usage reaches the level that perhaps when we've had more than a few talks in HelsinkiJS about something, it's reached some certain point, as an example. Now, these libraries that I consider safe to learn and have little risk in learning them are these reusable and smaller components, like I mentioned, underscore and jQuery. Even though jQuery is not small per se, but the I'd say the 80% of its features can be put into a very small package. So learning these can give me this kind of like a tool belt or a toolkit. It's not really sexy, let's say, to say that I know underscore or jQuery, that I'm not a specialist in some certain place. It's like a jack of all trades and master of none. But after that we get the specialization, and when we specialize in one or two frameworks or technologies and combine that with the general knowledge of many smaller things, we can consider ourselves as this thing called a T-shaped employee. So if you've never heard of this, there's a link on my last slide to Valve Software's this new employee handbook. They have lots of cool stuff there, and that's the place where I first came up with this term. So in short, it's a person who knows a lot about many things and is a specialist in a few, or an expert in a few. So that's the kind of person we actually look here to hire usually, and we consider it an optimal type of person. So just to wrap it up, think about what to study. That's kind of obvious, right? You don't need to be a genius to figure that one out, and look at the bigger picture, and that's about trying to find out the underlying patterns that exist in different technologies and trends. And even if these larger frameworks seem invest very big to learn, and you need to invest much time in them, don't be afraid. Just go ahead and just try something. So I'm not trying to discourage you here, but encourage rather. And once in a while pause and reflect on what you're doing, what you're learning, and if it's still relevant. And then I have my last slide about sources, and for me there I can tell where I usually learn this stuff, and after that maybe you can tell me where you learn stuff. So basically Twitter, blogs, articles from Reddit, Hacker News, JavaScript weekly newsletter. I listen to podcasts, and most importantly, the most time efficient way is to get yourself in a group, usually colleagues who filter the kind of the signal out of all this noise of stuff. And of course, going to events. And just by reading and trying to figure out what's going on, you should also do stuff and try them out and learn by doing. So if you have any tips, you can raise your hand right now or talk about them later, of course. Right, and yeah, I think that's it. I hope you got some ideas, at least from this, and some thoughts rose in your heads, and yeah, that's it.
Yeah, I guess we can take a few questions or comments. Or
Yeah, exactly.
Sure.
There's a
Used often and the title is that the abundance of JavaScript libraries.
Yeah.
And you said it's a problem, but you really gave only like one reason why it is a problem, that the community effort is spread. And I don't really see that and then the other libraries will have a fewer number of people. And could you please just summarize why you think the abundance is a problem?
Yeah, I think I said or tried to say it's both a problem and a good thing. The problem it's mostly because people they don't know how to keep up with the rate of change. I think that's the biggest problem that we think we have, so to speak. Of course, having different kind of branches then it can be good also, since there's experimentation and so on. So it's not totally bad even on that sense. So the problem here, I guess, was mostly our feeling of inability to keep up. I don't know if that, yeah.
And I think we will also discuss the average shelf life of a JavaScript product. If you think of like Angular.js 1.x, and then they say that this is game over, man, game over. We're going to release the Angular.js 2, and it's like 1.5 years old or something like that. If you're an enterprise company and you want to rely on something, so, and this flood of new and new and new and new keeps making the shelf life of a library very short, and we think that's a problem, or what a potential trouble source at least.
And also what I think that everybody should take a look at, when you are trying to find your libraries and components, don't just take it for the documentation, but actually read the code, review the code yourself, what they're actually accomplishing inside the code, and see if they're actually testing the resolutions that they claim to resolve. So not just trusting the developer and its documentation, but actually go through the code yourself and review if this is something that you need, and do you really need it as a dependency, or can you like basically mimic the effect yourself?
Yeah, no, yeah. Also, if you look at the code and you see it's total madness, you can probably infer from that it's difficult to maintain and keep up to date and so on. So it will stagnate, maybe.
Yeah. One really good example that we found out today was, in example, if you look for React time ago kind of component, you Google that, you will get two results: React time ago and React awesome time ago, or something like that. And that awesome time ago actually depends on React time ago plus moment plus some other third party, and it does only thing that component does is an if else. And just chooses one of those external dependencies. So do not also always trust those components. That's what I was meaning. Read the code, but what it actually does, the awesomeness of the component.
Yeah, I had actually had some speaker notes about this thing, but the slides.com didn't really handle this network here, but I had this point about these combinatory libraries that take two libraries and introduce an API that makes everything easier, but actually what they do is they glue these two versions of these libraries together, and then they're dependent on one maintainer probably. So one of the libraries gets updated, you end up with this old stuff that you need to replace yourself or just wait.
Yeah, so I think the thing with dependencies is a very good point. I don't think it used to be as problematic before, where like you had one depth of sort of dependency in your JS library. You had jQuery and Sizzle or whatever, and that was it. Nowadays with NPM, it's so easy to add dependencies, and this kind of philosophy of having small packages that do one thing well has really spread. But since there's so many packages, you have these massive dependency trees with all sorts of cruft that gets pulled in per package, and even though like the package itself might be okay, the thing it depends on might not necessarily be or properly maintained, and it creates this kind of problem that you don't know if the package you rely on is necessarily going to be around a year from now.
Again, it's a good and a bad thing at the same time.
And also the peer dependencies of these days, NPMs, usually, if they are like basically wrongly defined, the dependency versions, you will end up, you cannot actually update that component because its peer dependency is unresolvable against your other dependencies. Like if you use React and then you want to use React A11Y component, you cannot use it if you use the latest React because that one definitely, like it says explicitly that it requires older version of React. So there comes also these kind of issues. You never can update.
Yeah.
Anyway, this sounds like a discussion to be had over a beer. In fact, many beers. Maybe one last one.
Yeah, I could just quickly comment that I usually look at the packages of JSON as well, because that tells a lot about the packages. There's a lot of like outdated libraries and other things. I just skip over the library. I don't really care. I might look at what it does and mimic the effect or find another one, but it's a good indicator whether it's a good or bad library. This works in all the languages like PHP, you name it.
Yeah. Right.
All right, thanks. Anton is next.
Yes, so actually I wanted to suggest maybe to make a short break, like 5 minutes.
We'll have it in because we got 4 talks total.
Okay.
So we'll have one break after you.
If everybody is up to the next presentation, so let's continue. Like first, let me introduce myself. My name is Anton Ivanov. I moved to Helsinki like in the summer of last year. Before that, for almost 3 years, I was working in Amsterdam, and even before that, I was like kind of like in a previous life, I was a Java developer back in St. Petersburg. So, and but since 2011, roughly, I started focusing more on front end and on JavaScript. And one of the things that one of the things that actually I was relatively lucky, I guess, to work with from the very beginning is like component-based development, and that's what I wanted to talk about during this presentation. And you see the subtitle, Web Components, Polymer, React, Angular. So also I wanted to talk not only about some abstract stuff, but provide some examples from real life. And like there was a very good quote from the last presentation, like understanding is perceiving patterns. So hopefully after this presentation we will see some patterns. So really those things, when it comes to creating reusable components, they share a lot and in the philosophy. So let's start. So why should we think about components and like, actually it's quite obvious to anybody who wrote some code in their life, because like creating kind of reusable models means that your code base is more maintainable. You can actually easily just plug in ready things, and instead of like doing this boilerplate like code generation by yourself. And actually the ideas that we will be talking, they are in a lot of ways they are similar to ideas that are behind creating classes or functions, like decomposing your applications into those things. So really it's just a familiar concept, it's just slightly in a different area where we are not that used to it. So let's start. Okay, I took some image from an old website. Yeah, it's a bit hard to believe, but I don't actually remember this. It was a long time ago, so that's how the Apple site looked like in 1997. So it's like you can see it's very basic, and it's so that's what kind of HTML was designed for initially, the sites like this. So, and now we are in 2015, and I'm not sure how well you can see it, probably not. It's a screenshot, just an example of some application. It's like Cloud9 IDE, so it's entirely browser-based, so it's a web application. As you can see, there are like checkboxes, like some like dialects, and lots of stuff. So, and it looks really like a desktop app. So the web applications are really now much, so they are like real applications, and they call for the same techniques that we are used to doing like development in many other areas. So another example of a web application, like I have it in my hand. So it's like Firefox OS-based phone. So it's actually an entire operating system with a web application. So it's pretty far away from that Apple site that we saw. But the problem is that, okay, if you look at some website now or web app, that's often the picture that we would see. So here I opened Firebark and Wikipedia. So you see we have like some tabs, and we have lots of markup for those two tabs. You don't see it like what exactly it is, and it doesn't matter. It's just like lots of divs, fools, leaves, and so on. So it's like what is called kind of like a div soup. And also styles, quite a lot of them. And if you remember, like HTML, what is HTML? HTML is just like a way to semantically structure document. So it should, ideally, it should like communicate the semantics of the document. So here, if you look at this, it doesn't communicate the semantics. So it's some low-level stuff that we can hardly match with what is displayed on our web page. Okay, a bit of philosophy. So yeah, the thing is, like what we really are looking for with web application development is kind of quite often, like in many other areas, have anybody of you actually programmed in Lisp? So, okay, so for at least for a couple of people, what I'm saying now should be quite familiar. So really, the idea is that in order to solve some problem, what we should do first is like create a simple language in which the solution to this problem is really simple. So, and most of the effort in solving a problem is actually creating this language and like not solving the problem itself, because the solution once we have this language. It's quite obvious. So powerful language. So that's, by the way, the book that I still want to read fully. So far only excerpts, and it's, well, quite nice book. There was like a course of video lectures. I think it's from the end of 80s. It's about Scheme, like Lisp dialect. So there is a very interesting fragment in that book. So it talks about powerful languages. So what is a powerful language? Like we said, we might need a language if we want to solve some problem. Like language is a tool for describing the problem and solution for the problem. So every powerful language has three mechanisms. And I will just read out this slide because, yeah, it's sort of important. Like primitive expressions. So simplest entities the language is concerned with. So in our case, those would be, if we look at the web page, those are like those tags, let's say. Means of combination, by which compound elements are built from simpler ones. So in normal programs, this means like composing statements together, working program. Here it means like putting all those HTML elements together to get an HTML document. And the thing that is actually, that has been missing until those frameworks and standards that I'm talking in this article presentation. So what has been missing is means of abstraction. So, and it's a very important one. So it's like in your favorite programming language, you can say that, okay, this piece of code is just a function, and then you call it somewhere else. And that code that calls it, it does not concern itself with what it actually, like how it's implemented. It's just a function. So here, like we need means of abstraction. So we need to say, okay, this is just another element, like all those standard elements, maybe. So, and this is fundamentally what this is about, like means of abstraction. Okay, so let's start with web components. So actually, maybe a bit like side note, like my experience with this stuff. Like I said, I started focusing on front-end development since 2011, and for me it was like I was mainly working with the framework that allowed to create custom components in a way very similar to how now it's standardized in the standard. This framework is called Ample SDK. So for the last 2-3 years, it's kind of, I guess, is not as active. So probably I would assume nobody of you like heard about it because it's kind of not that popular. So have anybody heard about Ample SDK? Well, yeah, no wonder. You can actually Google it and find it. Yeah, but the thing is, now we don't need it as much, I think, as because we have like more modern frameworks, and this stuff, it just becomes mainstream. So, probably you already heard about web components and Polymer. I assume that everybody heard about React and Angular because those are like two of the most popular repositories on GitHub in the JavaScript section. So how many of you heard about web components or Polymer? Okay, good, that's quite many people. So my experience here, it comes mainly from that framework that has very similar ideas, and actually according to his author, like the guys who were writing these standards, they actually consulted him about like, okay, how do we standardize this? Yeah, and React and Angular, yeah, I guess, yeah, those are quite familiar. But still, we will discuss them. So let's first take a look at web components. So first thing that I personally find when I try to find some articles on the web and so on, it's just total confusion. Like, what is this web components? How is it related to Angular? And there are articles like, will Polymer kill Angular or something like this? So like clearly, like not. There is some lack of understanding how all of those are related to each other and what those are. So first, let's start talking about web components. And those things that we will be talking about, like web components, Polymer, React, and Angular, they are actually different. And comparing them, it's a bit like comparing apples and oranges. So web components, it's a set of standards. So it's not a framework, it's not a library, it's just a set of standards. Like, I don't know, DOM. And this set of standards defines how to create, how to create reusable components for your web app. And this means, okay, so we will go through some of the like concrete technologies that, some of the concrete standards that are introduced a bit later, but fundamentally this is about like bundling your code, your web app, bundling reusable components for this web app, and not just like already now you can do this, like create some JavaScript class like objects or something like this and reuse them, but that's not for real, because in the web app, we don't just have JavaScript code, we also have markup and styles, and those quite often are just like, well, you saw that slide with Wikipedia, like a div soup. So, okay, so first, well, those are really simple. So HTML imports basically just allows you to import HTML files into other HTML files. So, like I said, it's not just importing CSS or like JavaScript, it's importing the whole file. Okay. Next thing, registering custom elements. So, well, like we already have like some standard elements, I don't know, like div, footer, section, and so on, we can just as well define our own HTML elements and then use them with all the standard APIs like create element and like query selector. It will just work. So the idea is that we can extend HTML. So that's how we do it. Just like document, register, element, let's say component breadcrumbs, and we provide some prototype. And here we also inherit from HTML element so that we actually get all those like standard methods to work. The next core concept related to web components is shadow DOM. So maybe we are going a bit too quickly. You can just read up it later. It just, so we will try to discuss more like high-level ideas when we compare those things. So shadow DOM, basically the idea is that we should be able to hide implementation details, and yeah, and actually you already, like, if you look at the video element in Chrome, you will see that, and if you check the checkbox like show shadow DOM, you will see that actually behind this video player there is quite a lot of HTML. So it's actually that shadow DOM, that's what is hidden from you. For you, it's just like video element. So all the implementation details there in the shadow DOM, this kind of like isolated, encapsulated fragment of HTML attached to this element. And that's what we are also given the ability to do here. Like we can just say create shadow root, and yeah, then we can append whatever HTML we would like to it. Yeah, like I said, already used in video in Chrome. So that's the actual shadow root. So here is the video element. and there is some divs, inputs, and so on. Okay, and now the last piece from those web components standards that allows us to create those reusable components is templates. So while there are quite many libraries in JavaScript that do templating, and there are quite many ways to like include templates into your pages, but until very recently there was no standard, so there are all kinds of issues. Okay, if this is a script, is this executed, or like are the images loaded if we load this template, and so on. So here is the solution. So there is actually very simple, like template HTML tag, template element. It's completely inert until it is imported. So like you can just include it, and it will be ignored largely by the browser until you actually import it. And a very good thing about it is also that it allows you to bundle styles. So those CSS styles, they will be applied only to the content that will be generated that like from this template. So yeah, it's quite good for encapsulating styles, which by the way, I guess like React or Angular, they don't have yet, but they will probably in the future. Okay, yeah, like I said, to activate the template, it should be imported. There is some like API for doing this, so let's not go too much into details. And yeah, here we can look at the quick demo. So actually what I did, I just implemented a simple example of like a component. In this case, I just thought about doing like some kind of breadcrumb component. And as you can see, like in Firefox, it doesn't load by default because like there is some checkbox like DOM web components enable, and by default it's false. So it just says, okay, breadcrumbs element set path is not a function. But if we open the same thing in Chrome, yeah, you see that it's, well, it's a bit small. Okay, so it's kind of rendered. Well, it's very basic stuff, very simplistic. So just to kind of illustrate.
One question about web components. What is the take on composition? I mean, putting these reusable components inside each other.
Well, as far as I understand, so this like can be done. So you can actually, so those are just like HTML, like normal HTML elements. Of course, you have to then import those definitions inside the definition of your component. But yeah, I guess I didn't try to do that in this demo. But yeah, I would expect that it should work like this. And that's kind of the beauty of it. So it's like what we saw, it's just like some low-level mechanism. So it's not like I said, it's not a library, it's not a framework, it's just a set of standards. And by using this set of standards, we can just easily create new HTML elements with encapsulated markup and styles and behavior. And that's a big thing. And actually, I think that once this standard is like, okay, I don't know, does it make sense to... Okay, I will send a link to the code, you can actually browse through it. So there... Yeah, so I would expect that, for example, Angular or React, they would take advantage of those low-level mechanisms because, like, rather than trying to implement their own workarounds against, like, on top of old standards, they would just benefit from, like, native support of like, this stuff. Okay, so Polymer. I don't know, how much time do I have?
Can I ask a question?
Yes.
How is your demo working in Internet Explorer?
Yes, it doesn't work. So
It doesn't work.
Yes, but with this thing it will work. So good question.
It means standards is good, but
Yes.
Microsoft doing own standards.
Well, it just like I checked today. There is like under consideration. So all those things, HTML imports, template, custom elements, they are considering them for implementation. But it's not clear like when they are going to implement it. But a good news is that like we can, well, like you remember those times when DOM APIs didn't work consistently, like and so on, and browser APIs were just really awful because like all the browsers. Luckily for me, I started focusing on front end after that. So. But yeah, so basically what jQuery did back then, like in 2000s, Polymer does here. Like so, that's the next thing that I wanted to talk about. Probably you heard about it in relation to web components. So basically, it's a library built on top of web component standards. Well, a lot like jQuery, like 10 years ago. And what it does, it follows those standards pretty closely, and yeah, it brings support to Internet Explorer and to Firefox with some workarounds, because yeah, some things will still not work quite as we would like to, but yeah. And it also extends web components standards, so it also builds up something on top of it. Because like we discussed, web components is just like very low level. So it's, if you look at the code of the demo actually, and I will send the link, it is very low level stuff. It's like generating HTML, binding data to this like view, and it's just, it shouldn't be done like this. So I wouldn't use like web components alone. So it should be something that works with web components. Like Polymer is one such thing. So what it provides, it's also like advanced templating and inheritance for elements, and it also very nicely has a set of ready to extend useful components. And there are like very minor differences with the standards, so very minor. So like porting this example from pure like web components like standards to Polymer, it was like quite simple. But so okay, advanced templating, this is nothing new for you. If you like, it's almost, I guess, like any other templating library or framework that supports templating in JavaScript. Surprisingly, like those things about the maturity of Polymer and so on, I discovered that, for example, like loops were introduced something like a year ago or something. So it's still kind of in flux and not quite. I would think it's not quite, maybe not ready to use it as it is, maybe, but I don't know. I didn't try to use it in production on real projects. I just looked at it, like what it provides. So you see there are some like event binding, there is some event binding support, repeat, so support for loops, like I said. So there are also useful components like core item, core Ajax, core collapse, and so on. And it's very easy to extend those, like Polymer element, and extend, like let's say core Ajax, and there is Ajax support in our component. Okay, demo. Okay, I don't know, we can actually skip the demo because it will be the same thing.
Yeah, we'll trust you.
Yes, so yes, it works.
We believe you.
Yes, like looking at the code, well, it is still quite a lot of code. Yeah, let's open it. And there are actually two versions, like I said. So there is the version that is standards based, like that just doesn't use this like advanced templating features, and there is a version that is kind of shorter and it makes use of all those Polymer things. Okay, so now we come into probably more familiar territory. So I also wanted to talk.
Can I ask one question
yes.
about Polymer?
Yes.
It's for everyone. Who has read the source code of the polyfills that Polymer does? For example, Shadow DOM. It's madness.
It's
it
impossible.
does things that it's not supposed to do, and it works with Internet Explorer. At least I found that it's completely unusable with anything but Chrome, actually, in practice.
Well, yeah, like I said, so my impression also was, although I didn't try to use it on like real projects, my impression was that it's kind of being actively developed and maybe not quite ready. Like, it's interesting and I don't know, maybe, but still quite an early version.
A quick note on the Polymer, it's actually a Google project, so it has a really good backing, but the polyfills that they actually use, at least on the earlier version, when I used it, I tried to build a project on top of it, and I emphasize I tried. So the polyfills were actually a separated project from the core web component developers, and that was one of the main points of it.
Okay, yeah, thanks. Yeah, well, and actually another thing about Shadow DOM, so like we discussed, the point of having Shadow DOM is kind of encapsulating HTML. If the browser doesn't support Shadow DOM, then emulating this Shadow DOM, it just like adds some overhead for the library and for the developer, but it doesn't really isolate your HTML. You can still have like mess, like one component accessing HTML from another component and so on. So,
and
like,
it makes styling really hard.
Yes.
If you want to externally style those components.
Yes, and that's another thing. So that's why, like, one thing that is you probably should carry away from this talk is like web components standards. When they are adopted, they are really like promising that they will allow us to like reuse much more code. And I personally expect that many popular frameworks, they would make use of those standards. So that's why it's important maybe to start looking at them, because yeah, I already saw some articles about like how Angular can work with web components and so on. So yeah, I think it's coming. Okay, but now let's go to like, so maybe it was a bit like the future, like tomorrow, what we discussed now, that is rapidly becoming today. And here is like today, so like I wanted to focus on two particular like frameworks or libraries. React is a library, React.js or just React, and discuss how actually you can see there are many similar ideas to what we just saw with web components. Well, very briefly. So basically, what I will go very briefly over the features of React. And yeah, it just, again, we would like to have like 1,000 like feet like picture from above, like very like general. So don't despair if you don't understand some details or you didn't use React before. So like it's not that important actually. Just okay, just let's note this. So React is just a thing that basically transforms data into immutable HTML via a tree of components. It's a view library, it's not a framework. And components are essentially a bit like functions for generating HTML. So, and it kind of borrows many ideas from the world of functional programming. So really React components, they can be viewed like functions. And yes, it's declarative, and I think it's a very good design choice by React creators. Everything is a component, because what I saw in reality on real projects, let's say on Angular projects, although Angular allows to create reusable components, like this feature is just hidden somewhere down below, and people just don't create them, and they miss out on this opportunity to create reusable code. Okay, so it has own tree of components in memory, and it is kind of immutable HTML. It's kind of like immutable HTML, but you understand that if you kind of regenerate the whole of HTML, if we modify one field, this will not work, because I don't know, we will lose focus and it will be very expensive. So in reality, React is just a very clever thing that makes it seem, although as if HTML is immutable for us, but really just it will do re-rendering of only the parts that need re-rendering, so it is very clever about this. Okay, so component, it's basically, it has render methods, it has some lifecycle hooks, it has props, this is like immutable state, set as attributes, it has state, and we can build a hierarchy of components. And the data sort of flows from the root of this hierarchy to the leaf components. So each component can define how it renders itself. So it can say, okay, I render myself into this sequence of other components, and I pass this data to them. So this is kind of how data flows, and this is why this also like this architecture suggested by Facebook, it's called Flux. It's also the same idea, like data flow. So, okay, so a simple component, it's very, very simple, like gram separator in our demo. So it returns some XML, so some template, it's like XML like syntaxes, it's called JSX. Very declarative and functional like. So here you just see a definition like, okay, gram separator is something that has this title and this kind of label. Okay, nesting. There was a question about how do we nest web components. So here you see like React components. That's also one of the core ideas that we can actually nest them. So and this is very powerful because once we can build components from other components, it gets like really, so it is a very powerful mechanism of abstraction. Okay, like I also wanted to say a couple of words about Flux, because if you hear about React, you then hear about Flux. So Flux is just like some recommended architecture for React, and it specifies there is this kind of missing dimension for React, like it's a view library, but like we also have a lot of data in our application, and it flows. We receive it from the server, we send it to the models, we then render it. So, and okay, how do we receive it from the server? How do we send it from the models? How do those like nested models update each other and so on? So it is kind of might be missing. And then this architecture, it defines, it misses, it kind of fills out this missing gap, like how data should flow through one control point in the application. And yeah, here it's this picture from the React site. Let's just quickly skip it. But it's just like a couple of words about Flux. Okay, demo. Let's actually open source code.
Running out of time a little bit.
Oh, okay. Do I have like, how much? Like 5 minutes?
Yeah, right.
Okay, let's just know that it's like much shorter, and it reads much simpler than what we had with Polymer because of like this conceptual simplicity. Okay, so React, let's just quickly skip over it. It's very popular, so you can read this presentation later. Yeah, so basically one of the points that I wanted to make about React, and okay, sorry, it will be a bit of ranting about React because, well, everybody knows how great a framework this is, and now it's time for some criticism as well. So the thing is, like, it also allows to create components via directives, but this is kind of, and directives, they allow to do much more than just creating components. But the thing is, like, this feature is kind of hidden, and at least I quite often saw that people just don't utilize this feature. Like, it's almost, yeah, it's underused. And yeah, there are also like lots of things like services, factories, constants, and so on. And I inserted some Java book image. So like one of the developers, he's a former Java developer, like I am, and I understand like where all this stuff is coming from. So yeah, but like in the next version, it's very. Look at this. So it's like some alpha version. They have some site Angular.io, very little documentation. Look at this. Like that's basically what we were talking about, like with React and web components and so on. So it's like class my component constructor. So it will be. It seems, I don't know. I don't have much information about this, but it seems that it will be simplified and it will be more focused on components. So those drawbacks with complexity and so on, it seems that like they are understood. Okay, so demo. Okay, thinking in components, mental model. So also, the thing is, okay, it's just a different mode of thinking when you develop an application. You should just kind of split it already into components. Like, okay, this is a sidebar, a header, and so on. You can read more on the side of React. Okay, web components. Quick summary, web component just low-level standards. Polymer is a lot like jQuery, so it's just a library. If more is needed, like for practical projects, I would probably go with React or Angular. And I guess React philosophy more in line with JS. I personally like it more. So, but okay, future integration with web components. So I actually expect that those frameworks, they will start integrating. Okay, thank you. And
let's take a few questions, because I think it's a super interesting topic. So questions or comments or predictions as to the future of web components are welcome.
Yes, I have a comment, also a question. I like web components, it's great, and I use it every day work, but I use it in the project. I am the only front-end developer, or there are two of us. If you are in this quick project, you have a very strict process like designer, create the front end and UI, and then you integrate with your GSQ and GSQ. If we use component in that case, then designer have to go through our code to fix in the future. For example, before we deploy, you have a visual spec, and you want to change the padding, and you have to go through template setting and JS. It would be very hard in that case. So how do you think about that?
So if I understood the question, so like how does it work with when we have like design, some HTML created by designers?
And it's about the CSS styling also, but you can use web components with external CSS. So basically you can break out the CSS out of the component scope inside the same folder as a separated file. That, of course, then you have to have a build script, but still it's one way of doing it. And web components support that by standard, support external CSS files.
The second way, let's learn designers coding.
It's not always the optimal way to go.
Okay, yeah, good question. So, more questions? Okay, please.
So, just a small question about how do the web components interact, like with the standard of the web components? Do they have any ideas on how to interact with other elements? Like, do they just call parent and execute JavaScript, or do they have this kind of error hooks like you introduced in React?
Yeah, so basically, like this is just a mechanism for creating your own HTML elements, and they are the same, like they have kind of the same rights as other HTML elements. So you can use all the same selectors, you can generate, so you can make them produce some events that will like bubble and so on. So like it's very, that's the point, so it's very smooth integration and nothing specific is required, so all the standard APIs should work.
Also, that they also execute JavaScript inside those components.
Yes.
Do the components have access to the parent and the whole DOM?
Well,
in general, yes, but in general also it's a bad practice because that breaks down the component idea. So your whole idea of creating a component is that it doesn't matter where it is, it has its children and it knows its own stuff, and it doesn't really care what happens around him. People from around him tells him what to do, and they instruct that one. So that's the component hierarchy. Basically, similar in React, you have this data flow architecture.
Yeah, I understand that would be a bad practice, but if the standard doesn't give any like borders to it and allows doing this stupid stuff.
well, it evolves. So like, I would think, yeah, that this is kind of a bad practice. So I would expect that if you want to pass some information down to component, you should use some attribute like with normal HTML elements. So, like React does.
Okay, all right, thanks. So let's have like a 10-minute break.
Yeah, 10-minute break.
And 25 kids.
If somebody has to go to the bathroom, there's the bathroom over the jackets. And if somebody wants to go to smoke or something like that, please go outside where you get.
Something like that.
Or to get from fresh air or something.
It's a pretty vague description of doing something else. Air is starting to run out.
Different use for different
go through this quickly. And so I'm Jerry. I'm currently acting as a Chief Research Officer and a CTO in Kyrol Inc. here in Helsinki. And today I'm gonna go a quick overview about isomorphic application, building isomorphic applications, and then show a quick example how to do it with React.js. And yeah, so let's go forward. Quick question: how many of you? Almost works. Okay. Yep. Let's hope it stays there.
I can come there and hold it the whole time.
Yeah, that's right. So, quick question: how many of you know what isomorphic means? Good. Really good. So, first of all, it's comes from few words, Greek words, isos and morph, and it's a homomorphism from mathematics that actually admits an inverse. So, what the heck? Another word for it, is describes that if you look at the same entity in two different contexts, you should probably get the same thing. And we'll go even deeper a little bit about what it means in the web context. So this is a thing that it usually does, so if you don't know, ask. Some people say that it's the holy grail of web app, of like this state, that we know about web development. Basically the first impression is that on first page load the server will render to the client the full DOM, the fully all the elements that the DOM would naturally on like a previous way fetch dynamically to the empty div and build on top of that. Instead, right now we serve it the full DOM and the JavaScript just basically attaches hooks to it. And from that point on, it's a client-side app. But the initial load is fast, real fast. And there are various frameworks that support isomorphic by design, like Mojito, Meteor. Well, most of you, I think, have heard about or even used Meteor. Then, of course, React supports it. There's this renderer from Airbnb and all kinds of different variations. There's a lot of them, so I just named a few of them. The parts that you want to think about it is what can be the environment agnostics or even streamed or just like naturally supported by the browsers and the server environments. Like templating, there's handlebars that you can run both in the Node.js end, in example, and then in the browser side. Routing, there's a director.js kind of thing. Polymer.js for internationalization. Requests, super agent, works really well in the browser and in the backend. Model validations, Backbone.js, ATC, there's a lot of different kind of libraries for these kind of things. But why bother? Like, why isomorphism? There's, of course, there's the performance benefit. The initial page load is fast and it's actually cacheable. As long as you think about it a bit further, not just like rendering everything and then like hoping that, okay, I can cache this. Because of course there's the corner cases, if you have user sessions and all these kind of things, these are the things that you don't want to pre-populate in the server end. Instead, you will send everything else, and then later on, when the page loads and the JavaScript hooks in, it'll actually ask, like, do I have a user session, either through Ajax or some other means, and then renders those like extra buttons and tools on top of your content that the user has only privileges to. Like in a normal page load, first the browser sends the request, downloads the skeleton HTML, downloads the JavaScript, evaluates the JavaScript, fetches the data from the API, and usually this is the place where you see the user starts seeing content. But in the isomorphic page load sequence, basically we download the full DOM, user sees content, JavaScript is downloaded and evaluated. So the life cycle of the user actually seeing something appear is much more faster, and this especially is beneficial for mobile websites and all these kind of things for faster user experience. And then also the SEO parts. So this is actually because it's full DOM, all the content is there, the title C or whatever the data that you're actually sending is already there, so it can be executed without JavaScript. So it's search engine optimized by default and crawlable. And the maintainability becomes because it's basically you have one shared code base that works both in the server end and in the front end. So you don't have to think about like managing this kind of like Angular code over there and then all the same logic, basically mimicking the same logic in the server end, like routing and these kind of privileges. And of course it brings, by this same means, it brings more testability because you can just write your tests once and they basically evaluate that they work both in the client side and in the server end. And a little bit of the history of the web architectures that we used to do. Like in the early days, of course, like people remember in the early 2000s and these that we used to do thin clients and fat servers. The UI was something that the clients paid us to do. We just wanted to concentrate on the back end. And this was basically the architecture that there was some kind of a UX and DOM manipulation, and then everything else was done in the server end, handled over there. And then a bit later with this Web 2.0 buzzword that started in '98 and then later on 2004 actually came into real life more or less to people's attention. We have these thin server and fat clients. So like Angular and Ember.js and all these kind of things, you have tendency to build this kind of architecture that basically most of the logic in your developed application, web applications happen in the client side, and you trust that the client is like powerful and it has more computing power than your servers, which I don't know why we ever decided to do it that way. And basically the server will just serve as a like thin wrapper for persistence and then the authentication logic and these kind of things that you don't want to expose to your clients. Then there's this basically a new way, the client server with shared interests. I like to call it the perfect marriage because you have your both sides, client and server, they have their own things and then they also have the shared common ground, and the architecture starts to look a bit like this. So you have the UX and then you share the application logic, view layer, routing, and then you have the storage layer and the authentication and the like secret parts in the server end. And on the view layer, of course, there you have the templating and internet installation and model valuation, model validations, all that kind of stuff. But is anyone actually using isomorphic these days? So there are a few of these smaller players that are actually using isomorphic in their everyday development, like Facebook, Instagram, Asana, Airbnb, and Yahoo Mail's actually newest version that is coming out soon is actually completely isomorphic also. And then of course the media framework, just to name a few. And here is actually a quick example, like really simple React example. In the left part, you can see a React component. All components, basically this is a hello world.js file, or .jsx actually at this point, because there's no build process, which we go later on. It defines its own dependencies. It could define like a require underscore, require whatever packages that you want. And here, I could leave out the prop types and get default props and all those kind of things, but I usually like to show a component where those are actually defined, because they also, in the same way, they document your component, like what does it actually expect having in the properties, and then it knows that, okay, if I don't get this, we could also define that React.types.string is required, and these kind of things that it would actually throw a warning to the console, both to the server end and in the front end, that you didn't get this required property. So this is a really, really simple component. Basically, it just returns, it renders itself a h1 tag with a hello, and then whatever was given in the message property to it as a tag. And by default, it says hello world. And on the right side, on the server end, this is one way of actually, like I think one of the most simplest way of exposing it as a isomorphic way. So in the server, we require the same React library. And on this case, because we don't use any build tools and all that to package everything, I require the Node.js file that allows us to actually include these components straight on the server side. Because there's this HTML, otherwise Node.js would throw an error like, WTF are you giving me? What is this H1 tag? So that actually React Node.js compiles this H1 to JavaScript definition. Like in React, if you know how React works, basically all those DOM tags are compiled from the JSX are compiled to native JavaScript, and it actually says React DOM element H1 and blah 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 JavaScript definition. So in the server, this is the abstraction. I abstracted the normal Express.js server creation to this .server file. So basically we just get from that build server function, we get Express.js that just serves itself, like nothing special in there. We can go through the code later on. But the important part is that we basically create a factory from this component class as the first statement. Then we build up this properties object and actually access the request query for demo purposes. We find there the message property and then populate it to the properties and pass it later on to the hello world component itself. And as you can see, we call this React render to string. So we tell the React that render our component to HTML. And in this case, I decided to just show like one single component, but of course we could have a component called application that in turn would require like hundreds of other components in directory, and those would depend on other components like nested levels. And in here we would just require the application component and pass our state that we want to deliver to it in here along these lines. But this is just to simplify things. And then finally we call res render. We just render this index.html file that does nothing else, that has an empty body tag basically, and then takes in the HTML and just includes it in the template. Because at this point that HTML value is actually a fully rendered HTML DOM that has these React directives attached to it as properties or attributes in a HTML sentences, and then it renders it. For now I'll show a quick demo of it, of going here. Each way, there. So yeah, this is it running in here, and now if we pass the query parameter like this, it works as specified, luckily, so no demo effect there. And this simplistic code. And here we can see that this is actually what the server serves us. So there's this H1 tag, and then this React magic happening over here. So React creates on every single element that it creates unique IDs and checksums. So these checksums are actually pretty neat in a sense that if your server, when it actually sends payload, and your UI takes over once on that and tries to render itself on top of it, attach these hooks. So it'll actually calculate to this, it has to match these same checksums. So if your React, if your client cannot compute to these same checksums, you will get a warning to your console log that says that, hey, your server didn't send us the exact same thing that I was supposed to render. So those states interlap, and it actually then the client takes over and re-renders everything. So if you have any of these kind of things, you will lose all the benefits of isomorphic design at that point. So it's a good thing to follow your console log when developing React. But other than that, it's just pretty simple out message.
So
and here,
one question.
Yeah.
Did you explain, maybe I missed, how the state is transferred from the server to the
yes. I transferred it in, if we go back again here to the presentation. Jump on this. So here basically we collect the properties from the query parameters, so the URL query parameters, the Express.js way. And here, once we initialize this, basically we give it to the constructor of the factory of that component. So normally, also here, this would be an app, and you could set the base state here. Like this is the raw way of doing things. There's also better ways to do when you have a lot of state to pass on to the components. There are other ways of doing that, but this is one of the simplest way of example of showing how to pass the state from the server, in the server to the component itself. And also I could have shown, but yeah, I didn't expose the window.react that still for some reason it shouldn't require it anymore, but oh well, of course, because I don't load it in the UI. But when you do actually a React and you serve the same component to the client, you will have this in Chrome. You can install this React developer tool, which is really comes in handy. You can check out all the states of the components and what values it has, what properties it has, who was its parents, and all that kind of stuff. So you can follow that. It's a really good tool to have. It currently works in Chrome, I think, only. And where's my mouse? There you are. And if you look a little bit about with the code, there's let's see, just quickly show that basically the server doesn't do anything. It's a little bit bigger, except then just gets the Express server and sets the view engine, and then our index.html does nothing else than just passes the DOM. And yeah, that's like one of the most simplest example I could come up with how to show that. And a little bit more if we go a bit further in here. But what you want to do in production mode, of course, when you actually start developing your applications, you want to have a build process in your development. I think everybody of you who build these days web app has a build process, that either using Webpack or Browserify, or this kind of using Grunt or Gulp or these kind of task managements to combine your SAS files, minimize JS and all that. And for that, in example, for Grunt and Gulp, there's a really good tools available for doing this kind of React kind of way. So you can handle the requires, etc. calls efficiently on both sides. So you can actually, because all components by state define their own dependencies, so you can actually build a lot of these like separated, like how to say, minimal build files that you include when you actually need them in the browser, and then they have their own dependencies. You can make the dependency files and these external dependencies really low that you transfer to the client side. And I have this kind of project that I published nearly a month ago to the HelsinkiJS also. It was my take on how to start quickly with the React Bootstrap libraries, building these kind of isomorphic applications. So I'll quickly go through that. It's hard to actually type this way. Yeah. Yeah, so basically here, once you do a pull of this and npm install, then you can run tests with Karma and unit tests with the backend with Mocha. And then to just run the site, you can do this kind of a site dev. We could actually try this real quick. If we do it the full way. There's my terminal. There we have one. There's my mouse. There we go. Let's go there. It doesn't really matter. If we have internets, yes, we have internets. So I don't usually do live coding, but this is live coding. It's just live installing. So bear with me a moment. So this actually, this piece of example has some libraries that I've evaluated when starting to build these kind of in a larger scale. So it has quite a dependencies. If you look at the package.js on, it has it looks scary how much, but these are development dependencies, and these are basically the build tools that you want to have. Like it has all kind of cleanup scripts and all that kind of stuff, and some that are actually not needed anymore. But yeah, this just includes a lot of different libraries for show. Basically, only things that are required from this that I use basically on this framework is the alt library, then the ISO library, and React router. Those are basically the minimum required. These are just for the other parts that the example shows. Now we should have the installation done. Yeah, let's do npm run test web just to see if everything is working. So basically here the web tests is I launch Phantom.js. We could also launch different browsers for this one to test out the components in the browser environments. Where did it go? Oh, here. Sorry about that. So let's just quickly, we can add here, if you've used Karma and this, you can know that you can just run the test again. Oh, man. Yeah. So basically it's just testing out that the components actually act as they're supposed to act, both in the server environment also, and just a quick look of how to test, what the test actually does in this simple web page. We have a few tests here. We have this kind of an application test. Before each, we create this kind of a document element div. Then we also, because we have used a React router, so we actually trigger a route that happens in the browser, like push state route, and render the element, the application element to the DOM, and then we check that the component should be existing. React test utils find rendered component with type, and its state, we access its state, internal state in the unit tests and say that, okay, its current user should be null. And then, as you know, the React uses this Flux event base, but in here actually I don't use Flux, but I still use the unidirectional data flow. So there's immutable states of application state is always mutable. But here I check again that the current user should be null, and then I actually trigger an action that update user object. And this action, instead, we have a store, authentication store, that listens these actions, and then when this update user action is triggered, it'll basically update its state and say that, okay, now I have user, and because of the application component, it listens to that store, and whenever that store gets changed, gets updated and re-rendered. So now, once that action gets triggered, we can say that app component state current user ID is actually this one. So it works as specified. And quick look for how to actually run the site. Maybe I could read my own component site dev. Yeah. So now when I run this site, it actually runs through all the build process, grunts file, lints them, and make sure that everything should be running fine. And now we should be able to go to the local host. And be created with the isomorphic application. So here we see that if we check out the source of this page, we see that the whole DOM is actually pre-rendered from the server. And then when we actually click here, we have a push state happening, so we don't reload any page, we just change our route, and our React application re-renders the page. So now the JS application has taken over and works as defined. But now if I actually force refresh this page, it's exactly the same state, so it doesn't affect it. And now I can press back, and it's a JS app taking over. So we use push state, and that's it. And at the server end, for handling this quick review how to serve in the server end the routes, in example, not that one. Basically, the only route that you need is this kind of a star route. This is the final route that gets handled, and well, basically this is the main route. But this main route bootstraps this your whole application, populates the data to the stores, and then works its magic. So this is a good example of, it shows a little bit like here we can do a login. So now so we are now logged in. It sends some password stuff. And now if we check this, here is actually, you can see the React tools. You can follow like your application tree, all the components, check the component states, what it has, all this kind of thing. But if we check out the console, we see that our out store gets triggered a do logging feature, and then the store updated the user. And if I close this a little bit, and we refresh this page, we see that it actually does what it expected. So the server didn't send us the user. I think we can see a little flicker over there. Yeah. So the server didn't send this user object on top of the wire, but this React application knew that, okay, I have a user state, so please fetch me the user, and then like update the parts of the website that requires that user interaction. So here we can see we actually inspect, well, not actually inspect the element, but view the page source. We should be able to find out that there. Actually, the DOM that received has still the login button, but the view that we see doesn't have it anymore because the React app has taken over and fetched the user and then updated the store so the application knows how to change its state. But yeah, that's one like this kind of a library that you can investigate a little bit, like how to do this kind of isomorphic applications with React. Where is it? Oh, it went there. Okay, thank you. Any questions? Yeah, no question.
Okay, so any problems there? Anything that doesn't work that should work, or any other sort of challenges? What's the CPU load like on a server?
Yeah, that's something that I'm pretty ashamed that I hadn't enough time to actually hadn't enough time to go through and actually include benchmarks to this test. But the initial benchmark that we've done is they look really nice. You can do them like also yourself, but I will try to post to the HelsinkiJS proper benchmark results. But the initial benchmark that we've done are really promising, both in the way to just use the web app, well, React.js itself, because it's shadow DOM implementation, and the like magic of how it updates the DOM, and only the parts of DOM that actually needs change. Because of the checksum calculation of that, it does it really brilliantly, and that in itself brings a lot of performance enhancements. And then of course there's this when you actually shove the browser, the full DOM already, so the browser doesn't need to do that much JS stuff itself. So the benchmarks are really good. But I will post later on the numbers and some graphs for the HelsinkiJS.
Do you have any solutions for the flickering that happens there?
Yeah, you can do that. You have well, of course, you can do quite a lot of things for that. In example, placeholder loaders, or like this one just don't have real styling. So thank you.
All right. So yeah, let's conclude the evening by shedding some light on some of the darker corners of Angular. I know there's a lot of people in this room who use Angular, who develop or maintain apps with it, so what I'm going to say is probably going to be most useful for those of you, but hopefully will be interesting for everyone else as well. And I want to focus on directives in specific, partly because they're sort of the defining feature of Angular. Like most other frameworks haven't had this ability to extend HTML essentially with your own elements and attributes and then build your app based on those. although we do now have things like the web component standard, as we already saw today, but it's been like the Angular selling point for a lot of people. But we also, I think, need to talk about directives because they're kind of difficult. So this is the directive API in Angular. You have like 15 or so different configuration options that you can tweak, all of which kind of affect each other in subtle ways. So you have to kind of know all this stuff if you really want to use it effectively. And the thing is, most people actually don't. I kind of don't. I still don't understand all of the combinations that you can make here. And that's not nice because you want to feel like you're in control when you're using a framework. Like you want to feel like I'm using it effectively. Like there's nothing that I'm doing wrong which would enable me to eliminate half of my code, like which is the feeling you often get when you don't know something. So what I often do when the API doesn't like communicate itself well enough to me is I go to the source code. Like that's the beauty of open source. We have already talked about that today as well, to actually read the source code of the things that you use. And you can do this with compile, the Angular directive compiler. It's going to be in this one file in the repository. And this is what it looks like.
See you tomorrow.
That's the best part.
Yeah, yeah, I like that convention over there.
Yeah. That was actually just removed yesterday.
Yeah.
So what we have here is like 1,300 lines of pretty dense JavaScript code in about 100 functions that are sometimes deeply nested. All kinds of features inside that same file that do all kinds of things in addition to the actual compilation. And that's also a problem if you want to figure out a certain feature, like how do you find it in the first place, and then how do you separate it from everything else that's going on in there, and how do you actually approach this. So what I've done, the strategy I've adopted, is to look past the matrix and actually flip things around a bit and to, instead of trying to read the source code, to actually write the source code, and to actually kind of imitate what the Angular team is doing by building my own versions of all of those features. And in the process, sort of building my understanding of what's inside the Angular framework. It's not because I need my own version of the Angular framework. I actually don't use my own version of it. I just do it as a learning tool. So today, I'm going to share a few things about the compiler that I think are interesting in this way. Those are going to be kind of, I think, the core features of the Angular compiler. I'm not going to do all of what we just saw. That would take a week, but there's like this smaller core that we can talk about. That has to do with three things. One is the actual DOM compilation that the thing does, and the other is the linking between directives and scopes that is done there, and the third is how the scope inheritance happens inside the compiler. So let's get right into it and talk about DOM compilation. Compilation is one of those words that can mean so many different things that we should probably define it first. In the context of Angular, what we have when we talk about compilation is this function or process that has inputs and outputs. The inputs to the process are a collection of directives that you want to apply and a piece of DOM that you want to apply them to. And what it does, it combines those two, produces a compiled DOM. So it applies the directives to the DOM. That's all it really means. And how that looks like in code is you have these things called directives, which you can register into this compile provider. And each directive has a name, such as my class in this case, and a factory function that produces the directive. And then that factory function eventually returns one of these objects that has all these configuration options that we saw. This one just has one called compile, which is a function that takes an element and applies the directive to the element. And here's where the directives gets to do whatever they do to transform or add behavior to the element or replace it even. This one just simply adds a CSS class to it to keep things simple in the example. what you then have is you have a piece of HTML where you have things that you want to apply the directives to. What you do is you grab that element from the page, you wrap it inside this Angular element wrapper, and you feed it into the compile service. And you expect then the compilation to occur and the directives to do their thing. And what you end up with is another DOM, the mutated DOM where those directives have been applied and whatever they do has happened. So to build something like this, we first of all need the compile provider into which we can register these directives. And this had this method called directive that takes these two arguments, the name of the directive and the factory function. And what that method does is it puts the directive into this internal storage we have in the provider. It's just an object whose keys are directive names and values are the actual directives. And what's actually happening also is that in Angular you can actually have several directives for each name, so we have to support that, and we actually make the values in this object arrays of the directive factories, so you can have several factories of directives for each name. As many times as you register a directive, you get copies of it essentially, or different directives with the same name. And this whole thing is integrated to the Angular dependency injection system as well, which we can do by injecting provide here. What we're going to do is actually register a factory for each time we see a new directive name. This is just a normal Angular factory, which has the name of based on the directive name, but followed by the string directive. And what that does is when you inject actually something by that name, it instantiates those directives. And it does it by looking up the factories from that object that we have, and then calling each of those factories. And we call them with dependency injection support because directives may have dependencies, so we use the injector to do that. We map over that array and call the injector's invoke method for each directive, and that gives us the objects that the factories actually produce. And then, as this is an Angular provider, it has the method that every Angular provider has, which is get, which actually makes that thing that we want, which in this case is the compile method. And that's what you get when you actually inject compile into your Angular app. It's made by this provider. That's a function that takes the element, and that should then apply directives to that element. So we can actually move on to talk about what that actually means. The first thing the compile method does is actually just delegate all the work to a helper function called compile node that we'll introduce inside here. That's a function that takes an element and we want it to compile that element. And there are a couple of steps to that. And the first one is to actually find all the directives that should be matched to this particular element. And for that, we make another helper function called collect directives. That's a function that we expect to return an array of all the directives that we know about that match to this element. And that matching can be done in three different ways. So you can match directives to an element by looking at the element's tag name or the element name. So we do that. Then you can match directives to an element by looking at the attribute names on that element. And thirdly, you can do it by looking at the CSS class names of the element. And what we do is we try all of those three strategies. We combine the results we get from all of them and return this combined array of all of those. Let's look at how that matching then happens. First, the matching of directives to elements by the element tag name. What we do is we just look up the element's node name, which we get from the standard DOM attribute node name. And that's going to be a kind of uppercase hyphenated string. Our directives are camel case strings, or the names of them are, so we need to use low dash to camel case that name. Then we put on the actual directive suffix to it to get the sort of full directive name. And then we can just look up from this directives object that we set up earlier. Does it have something for this particular camel-cased directive name? And if it does, we can get the corresponding directive objects by asking them from the injector, which will then invoke that factory that we set up earlier. and we need to inject the injector here to do that as well. And then finally, if we don't find anything, we just return an empty array. So we're not going to return undefined from this function, even if we don't have any directives. We just need to make a loop over the attributes because there may be several for the elements. So we just take each attribute name, camel case it, put the suffix in there, check from the storage, do we have directives with this attribute name? If we do, we instantiate them, put them into this combined result array, and return it. And thirdly, for CSS classes, we do pretty much exactly the same thing. Make a result array, loop over the class list, standard class list of the element. Each CSS class name we camel case, put the suffix in, check the store. If we have any directives, instantiate them, and put them in the results. And at the end of all of that, we have this big array of all the directives that match to this element in any of those three ways. And then all we need to do is actually apply those to the elements. So we go back to the compile node, where we now have this array of directives. So we loop over it. And for each of those that we have found, we simply call the compile method for the element. And that's where the directives compile method gets called. And that's where our example directive would add the CSS class. And some other directive would do something else. But that's how it connects. And before we're done with the compilation, there's one more thing we should do, which is that if you think of the compile service, when you give it some element, you don't expect it to just compile that element, but to actually compile the whole DOM tree that starts from that element, all the child nodes as well. So we need to take care of those as well. And that's actually pretty simple to do now that we have this function here, compile node, because we can simply recursively invoke it for each of those child nodes. So for each child node, the process of collecting directives, applying them, begins again, and we end up with this depth-first tree traversal, essentially, of the DOM tree, where we do the same trick for each node, and when we're done with the tree, we're done with the compilation. And that's how Angular does it in a simplified, simplified version of it. It's actually twice the code, probably, with all the corner cases I did not mention. But that brings us to linking then, which is sort of where we bring the rest of the Angular framework in. So what we have so far here is that this sort of somewhat useful thing, which is still kind of like a replacement for jQuery and nothing else. We have these matchers and some JavaScript code that we match to them. But linking is where we bring Angular into it, because linking brings in scopes. And if you have used Angular, you know how important they are. It's where you put your application data and functions, like it's how you share it between templates and directives and controllers. Scopes are where the change detection stuff is all implemented, so that's where you watch and digest and apply. And scopes are also where events are propagated. So that's where you broadcast and emit and listen to events. So much of the Angular application architecture is actually built on top of the scope implementation. And the process of combining scopes to directives is called linking, and that's what we'll do next. So let's first think of the processes again, what we have here. We have this compilation process that we already saw that combines directives to the DOM and produces a compiled DOM. But that actually has also a second output, which is a linker for that specific compilation. And that's another one of these processes that has inputs and outputs. And it sort of has this implied input of the compiled DOM, and it has an explicit input of a scope object, and it combines those two together to produce a linked DOM. And we'll see how that works. But there's this sort of one interesting trick to it, which is that there's no link service anywhere in Angular that you could inject. Instead, the linker is always an output of the compiler. And that's a strange way to do it, perhaps, but hopefully it'll make sense in a moment. How you use linking is you've probably done it yourself if you've used Angular. You can have directives that have this link method that takes a scope as well as an element, and it can then do whatever it wants with those two. So in this case, we still have a directive that simply adds a CSS class to an element, but this time the class is dynamically defined by the scope. It's sort of an input to the directive, so it doesn't know what the name of the class actually is. And the most low-level way you can make a link function is to have it as a return value of the compile method of the directive. There are other ways of doing it, more simple ways, but this is sort of what they all build on. So the link is a return value of compilation. And how you actually do the linking is that when you call that compile function, you have to grab the return value that you get from it, because that's going to be your link function for that particular compilation. And then you can later call that with a scope, essentially, and it'll then combine the scope to that same DOM that was originally compiled. And here we pass it the root scope, which you can do, or you can pass in some other scope. So we should make this also work in our implementation. So we now expect compile to return something. That something is the link function. So we add this return statement to the compile service. And in compile node is where we actually make that link function. And we'll call it the node link function. So that's a function that takes a scope. And we expect it to link this node. And linking this node, what that means actually is nothing more than applying the link functions of all these directives that we have found for this node to the element and the scope. So we need to collect those link functions. And that we'll do during compilation. So in this compile node method or function, we introduce this array of link functions. And then as we go over all those directives that we found and call compile on them, we grab their return values because those are each returning a link function to us. And we put those into this array. And when we're done with compilation, we have an array of link functions, one for each of those directives. And once we have those, we can just call them later when we get to the linking phase when that gets called. So we make a loop over those and call each one with the scope as well as the element. And that's how the directives link function is called. So in between the compilation and the linking, the link functions are sort of waiting in this function closure, essentially as an internal state of the linker, and that's why you don't need to supply them externally anymore. It's sort of remembered by the linker what exactly it needs to link. And there's one more thing about linking, which is again to look at the child node. So we recursively compile the whole tree. We need to link the whole tree as well. And the key to that is to look at how we recursively invoke that compile node function there for each of the child nodes, and to look at what compile node actually returns now. That's a node link function. So that means that when we want to link those child nodes, we need to grab the link functions that return by each of those recursive invocations of compile node, which we can do with map. So that gives us an array of those child node link functions. And then we can just call those two once we get to the linking. So we make another loop here over the child link functions and call each one. And what that is essentially just node link function recursively calling itself. It's just done in this roundabout way, but that's all that's happening there. And you may notice that we actually call the child link functions before linking the element's own link functions. And that's because what we have here are so-called post-link functions. And the definition of that is link functions that are called after child nodes have been linked. You can also have pre-link functions, which is another loop on top of the recursive linking there. But the default is post-link, and that's what we have in this case. And that's how linking happens. Actually, yeah, the last part we'll ignore because we don't have time, but we'll talk about inheritance, which happens during this linking. So there's this omission in our linker currently, which is that when you give it this scope, it's going to use that same scope for everything in your application. Like all the link functions everywhere in the tree will get the same scope. And any Angular developer knows that that's not actually what goes on in your application. You don't have this one global scope. You have this tree of scopes, which starts from the root scope and has any number of descendants that come and go during the lifetime of the application. But there is this hierarchy. And this actually becomes available during the linking process. And how that usually additionally looks like is that you have these two hierarchies in your app, which is the hierarchy of your DOM and the hierarchy of your scope tree, which have similar shapes. And that's because you have directives in your DOM that cause new scopes to be created, like ng controller. And that's how you end up with these parallel hierarchies. So how that looks like in code is you can have directives that have this attribute scope on them with the Boolean value true as the value. And that's saying that this directive is asking for an inherited scope to be created for it. And then the scope that gets linked to it gives that directive some privacy essentially, because it can put attributes on the scope and be relatively certain it's not going to mess up the attributes of the parent scope or the sibling nodes, because it's now no longer the surrounding scope, it's for this node only. So how that looks like, how we can make that work is we have to, during the compilation process, figure out if we see any directives that want to have the new scopes. And if we do, we're going to put it in this variable new scope dir. So as we go over those directives in that loop, and after we've linked each one, we can check if that directive or one of them has this scope attribute with a truthy value. And if it does, we just put it in this variable so we can later use it. And furthermore, we actually only allow at most one of these for each element. So if we see one of these directives but already saw one for this element, we just throw an exception, which is something you probably have seen if you've used directives much. But at the end of it, we have this variable that will have been assigned if there was at least one, or if there was one directive on this element that asked for scope. And then we can use that information during the linking process to check if there's something in that variable, just make a new scope. And we can do that by calling the new method on the scope that we were given, which gives us a child scope for that scope. And then we use that scope for everything from that point on. All the directives on this element, all the child elements are now using this child scope. And we basically don't use the parent scope or anything in that DOM subtree. And that's how you end up with these hierarchies of scopes, because we essentially replace the parent for certain DOM subtrees, and we do that recursively, since this whole process is recursive. And those are the three processes I wanted to show today. So there's a lot going on in that compiler, but I think there's also this sort of simpler core that you can actually understand if you just approach it from this way of actually building it up, instead of trying to find it from that file. It's in there, but it's not that simple. But hopefully, at least some of you now have a little bit better understanding of what exactly Angular does when it starts up, how it applies those directives to the DOM, what happens, how the scopes get created, how the link functions get called. Because it's often useful to know how the tools work when we use them. And if you want to get into this sort of thing in excruciating detail, this is what my book is all about. I've been writing it for 15 months now. It's at 800 pages at the moment, which is, believe me, much more than I ever wanted to write about Angular.js. But I've done it. I'm almost done with it now. And actually, you can get it for free today if you go to my website, buy the book, apply the coupon code that matches the last name of either this guy or
I'm honored. If you can spell my last name, you deserve to get it.
So, yeah, that's what I had. Thank you. Do we have time for questions?
Of course.
Any
But I think
questions?
everyone's so overwhelmed.
I am.
I have a quick question. How many people in the world know Angular as well as you do? Do you have an estimate?
It's difficult to say. I think most people have long before run away than I have. I can't answer that question. I feel like I know it well enough to use it now.
now it will just get old.
Yeah, now there's a new Angular coming out. Again, you don't know anything. But that's, that's just a program.
Yes, so considering the new Angular, I mean, now we know so much about 1.x.
Yeah.
What do you feel is good here and what is bad, and can you reflect upon Angular 2.0 that what is getting worse?
Well, with 2.0, I think a lot is getting better. One is that many of the features in that huge file simply won't be in Angular 2. The pruning features. Second is that if you look at the source code of Angular 2, even though it's kind of not done yet, you can actually understand it by reading it. That's a very nice thing. So it's actually, when there's like 50 different features that the directive system does, it's not all in one file in the new code base. It's like they've applied this thing called object-oriented design. Very useful. So they're like small files with specific roles in the source code that do certain things and that collaborate. And what's actually interesting to me is that I've been like working in dynamically typed languages for many years now, but since Angular 2 is written in TypeScript, that actually really helps when you're reading the source code. Like, you can look at a function signature and say, okay, these are the inputs, and that's the output. The types you can see from that, what it's supposed to give you. That's something you don't see when you look at like an ES5 code or any ECMAScript code, really. You have to kind of go deeper to see what it's doing. So kind of learning it by reading the source code is much easier. And as a user, I haven't actually built anything with Angular 2 yet, but I like what I'm hearing about essentially removing lots of features, and solving the same problems with sort of simpler constructs.
All right. Thank you very much. That was awesome. All right, I guess we'll wrap up now and continue to sauna. I don't know if Jesse wants to say anything about that, but before he does, I've got a couple of announcements. So first of all, big thanks to all of you for attending. Big thanks to Fraktio for organizing. Also, I wanted to say big thanks to Joonas here. All right, do you want to stand up? So Joonas has been the doorman, but I'm hoping that he'll take on a bigger role in the future. And even MC some of these events if I happen to not be available or whatever else, and even if I am. So basically the next event is going to be on the 11th of May already. So that should be good. Put that in your calendar. And then there's something a little bit special coming up on the 14th of May, which is that I'm organizing a JavaScript meetup in St. Petersburg. And I've timed it so that for those of you that don't want to get a visa, you can take the ferry in without a visa the night before and then come back the next day. So there's also a potential to have like HelsinkiJS on a boat. Anyway, I'll just put those dates in your calendar, and I'll shoot you all an email. I guess pretty soon, sometime this week. And yeah, just
extension date.
Oh, I didn't realize that. That was a coincidence. But anyway, hope to see as many of you as possible there. There's room. Oracle is actually hosting, and there's room for 180 people. So. So let's see how many we can get from Finland. Anyway, thanks again. Do you want to say a few words about the sauna and stuff?
Yeah, just a quick poll. How many you